So we talked about compound interest in a previous section, but let's review very quickly. Compound interest is different from simple interest in that you are calculating your interest and then adding that to your principal amount. And then the next time you calculate interest, you calculate it on that new amount that you have. Whereas simple interest, you are only calculating interest on the principal amount. And so the formula is given by the future value S is equal to the principal amount times the quantity 1 plus the interest rate over M, which is the number of times you are compounding per year. And then that quantity is raised to the MT power, where T is the number of years. So example 4 says Jim and Eden want to have $200,000 in Maura's college fund on her 18th birthday, and they want to know the impact on this goal of having $10,000 invested at 9.8% interest compounded quarterly on her first birthday. So part A says find the future value of the $10,000 investment. So let's remind ourselves the formula is S equals P times 1 plus R over M to the MT power. And what values do we know here? Well, we're trying to find S. We know that the initial investment is $10,000. We know that the interest rate is 0.098. And since we're compounding quarterly, that means that we are compounding 4 times per year. And then the M value again in the exponent is 4. And since the ending value would be her 18th birthday and the starting value is on her first birthday, that means that the number of years that pass is 17. So our T value is going to be 17. So let's see, how do we plug that into our calculator? So we have a starting value of 10,000 times 1 plus the fraction 0.098 divided by 4. So we want to use 2 parentheses there. And then our exponent is 4 times 17. And then if I press enter, we get $51,857.73. So if their initial investment is $10,000 under those conditions, after 17 years on her 18th birthday, that's how much they will have saved for, I'm guessing Maura is their daughter. I don't know. I don't know these people. Okay, B, find the amount of compound interest that the investment earns. So S is the total amount, and the way that we're going to figure out the amount of compound interest is we know that S is equal to the principal amount plus the interest. And so we know that S is $51,857.73. And we know that the principal amount is $10,000. So if we wanted to solve that for I, then we would just subtract the future value by $10,000. So then the amount of compound interest would be $41,857.73. Okay, part C says the future value found in part A is what percentage of their overall goal. And if you read back in the problem, they wanted to have, by her 18th birthday, they wanted to have $200,000 saved. So that would be our denominator. and then our numerator would be the future value. So I threw that into my calculator. If we are going to round it to 2 decimal places, it's approximately 25.93%. Okay. Example 5 says, what amount must be invested now to have $12,000 after 3 years if money is worth 6% compounded semi-annually? So really quickly, I just want to rewrite the formula, and let's plug in the values that we know. So the question is asking what amount must be invested now. So what that tells us is we're trying to solve for p, so hopefully we have all of the other unknown variables. So after the 3 years, we're going to have $12,000, so that would be our future value, S. P is the thing we don't know. Our interest rate is 0.06 or 6%, and we are compounding semi-annually, which means 2 times a year, and the number of years is 3. So we have 12,000 equals P times, I'm going to plug that quantity into my calculator. I went ahead and plugged that in, and then I'm going to divide both sides by that number to get P by itself. And so those will divide out, and P is approximately $10,049.81. So that must be invested now under those conditions in order to get $12,000 eventually. Now, the two types of interest that we've talked about so far were simple interest and compound interest. There is a third type, and that is continuously compounded interest. So if $P is invested for T years at a rate R expressed as a decimal compounded continuously, then the future value is given by the exponential function S equals P times E to the power of RT. Now, PERT. This might sound familiar to you. If it does not, then maybe get out from under your rock a little bit more. Just kidding. So PERT is in the outside world is a brand of shampoo. And so if you're ever like trying to remember compound interest versus continuously compounded interest, I like to think of it this way. Continuously compounded interest means that you are gaining interest all the time or continuously, even in the shower when you are using shampoo. So that's how I remember which formula goes with which scenario, because continuously compounded interest means you're getting interest all the time, even when you're in the shower using your PERT shampoo. Okay, example 6 says, find the future value if $1,000 is invested for 20 years at 8% compounded continuously. So S equals our initial value, $1,000, times E. Remember, E is that constant that is approximately 2.71. Our interest rate is 0.08, and then the number of years is 20. So if we throw that into our calculator, you should get that the future value is approximately $4,953.03. All right, example 7 says, what amount of money must be invested at 6.5% compounded continuously so that it will be worth $25,000 after 8 years? So let's remind ourselves of the formula. Remember, you're getting interest all the time. So we know that the future value is going to be 25,000. We don't know the initial value. That's the thing that we're solving for. And we know that the interest rate is 0.065 and the number of years is 8. So I'm going to throw the e to that exponent into the calculator. And we ended up getting that long decimal. And now if I want to solve for p, I'm going to divide that number on both sides. And so we get that p is approximately $14,863.01.